Do you guys, okay, I'm going to teach you guys how to use the synthetic filter feature, which is a brand new feature that's just been released in Insight. And it's a super powerful tool to separate sort of intermingled species. All right. I'm going to do this, what I'm going to do is I'm going to remove what's currently in our marked list. So right click on the marked list and go unmark selected. All right, so we right clicked on marked list and then selected unmark selected. So your marked list should be empty now. We're going to go back to our stores panel. So beneath the project panel here, click on the stores tab to go back to all your data set. Then I'm going to get you to right click on your folders and group by species auto ID. So species auto. So what we're going to do is we're going to pull out two species that are kind of close in frequency, just as a demonstration. So what we're going to do is we're going to mark all of the P. pip calls and all of the P. pygmaeus calls. All right, so the ones that are in this P. pip, we'll right click on that where it says 35 files. And we'll go mark selected. And then down to the P. pig, and we'll do the same. Right click on P. pig and then choose mark selected. So if we go over to the marked tab, you can see we've got a bunch of files here like this. All right. So to use the synthetic filter, basically what it is it plots one metric against another and then allows you to create a dynamic rule based on the relationship between those two metrics. It's way easier to visualize than it is to explain. So we'll go up to analysis, then synthetic filters. I'm not sure how good this is going to work with this existing data set. So, sorry, to bring everyone back up to speed, I open the synthetic filters window. For stores, I changed to the marked list and I've changed it to the average. I just want to see the average for each file, not per pulse. Per pulse can get very messy unless you are working with a very clean, curated data set. Right, so by default, it's currently just plotting characteristic frequency against characteristic frequency. So that's not going to tell you anything. That's the same thing. So obviously it's a straight line. But if I start looking at characteristic frequency versus the slope of the characteristic section, it's plotting the relationship between these two and it's grouping them by species based off color. So I can see they actually separate out very nicely using FC and SC. I can look at some other ones. Sometimes they won't plot out. So duration versus slope doesn't pull them apart very well. You can see they're completely scattered together. If I look at frequency of the knee versus slope, we can see they separate out pretty well together. So you can blunder about until you find something that pulls them apart, or you can try and use your brain and try and figure out what you think might pull them apart. But in any case, once you find two metrics where they separate out nicely, so an FYI, if you don't like these colors, you can always click on the box and change the color if you want. Then we'll click add rule. So over here, we'll create our synthetic filter rule. Then you're going to click and drag a line between the two. All right. And you may be able to grab the corner of that line. If not, you might need to increase the threshold a little bit. So over here, you can just pick one of the thresholds and increase it until you see like a box. Then what you want to do is you can click and drag the corner of that box to encompass one species. All right, so you can make it as broad or as tight as you feel is necessary, whatever you want to do. Okay, and that's basically what you're going to be filtering now, is any files that end up in this space here. All right, so essentially I've created a pipistrellus filter here. So I'll give the filter a name. I'll call it my pip filter, and I'll click save. Oh, sorry, that's not saving to my documents. All right, so now I have this filter that pulls out these two species that have overlapping characteristic frequency. So I can then go to, say, a search, and for criteria type, so I'll go to a filter, and I'm going to change it to synthetic filter. I can import that. I'm not going to go into too much detail in this because this is really more of the advanced level stuff, but I can basically add that synthetic filter and run a search for my full data set about it. Jess, you've got a question.
I was wondering if there is any difference where, for example, in the graph you just had with the ppig and the ppip, would it be better to make a rule based on the species with more points, or the one that's like more tightly, like, so because ppig has more points, would it be better to then draw the box and make a rule based on that? Or
it's a good question that I honestly don't have the answer to.
Okay.
Yeah, it might depend on your data set. If you felt that your reference data set really represented all of the variation of that species, then it might not matter. But let's say our pip was, reference data set wasn't great. We only had a handful of calls. You might be better off going with the one that's got a bigger data set to try and encompass that. So that's my only thought, but I couldn't really say definitely if one's better than another.
And would you, I don't know if you mentioned this just now, but would you say in general maybe it's better to exclude outlying points?
I personally haven't been. I've been creating, unless there's like an absolute, say there's this point up here, I wouldn't include that in anything. And in all likelihood, if you were to look at that file and open it up, it's probably going to be some random noise that's gotten the label. But I would definitely, if I was creating one for this, I would go broad and go across this whole sort of spectrum here. You can also change the axis if you need to, if you want to make it bigger or smaller or whatever. So I would definitely do that, because you're already going to be filtering down to this sort of frequency bandwidth. So whatever, these being like 40, 45 or whatever, 55. You're already defined, so you're better off going broader and seeing how it treats you. I've been doing really broad ones as long as the line's separating the two species, and I've been getting really good results. So like in Australia, I've been doing this with Goulds versus Rhytii, and also Nyctophilus versus Myotis, and I've been having great success with it. So yeah, it's been really good.
Yeah.
Any other questions? Oh, we did have a question, but then it seems like we figured it out. Is everyone all good? Need me to repeat any particular steps?
Actually, yeah, can you repeat after you get the rule?
Yep. So I'll just hold on. I'll remove it and I'll just create the rule again so that everyone's across it. So I'm going to add a rule. Click add rule, and then you click and drag between the two species. Then you want to increase your threshold. So you pick whichever axis and you increase the threshold a bit so you can sort of see a rectangle. And then you can click and drag the corners of that rectangle wherever you need them or want them to be. All right. So once you're happy with your filter, you give it a name. So I just created it for the opposite species now. So I'm going with pig filter. So I gave it a name up the top here and then click save. Oh, and I didn't click save as, so that's just overwritten the last one. But anyway, either save it to overwrite it or save as if you want to save a new one. All right. And if you want to go further down the line of how to run searches based off filters and things like that, we're going to cover that in the advanced level workshops.